Okay, we're now live. Okay, anybody want to take the first one? Number 3?
I'll go.
Okay.
Question 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. That's true.
Yes.
That's what we got. I'll do the second one. What requirements need to be met or need to be checked when performing an ANOVA hypothesis test? Mark all that apply, and I put the second and third.
Yep.
Okay.
All right, so question number 5. To check if each group is normally distributed, do the following. I clicked construct a QQ plot for each group. It was the bottom one.
Yeah. Yep.
Okay.
All right, number 6. We assume the variance in each group is the same if the following happens. I have that the largest variance is less than 4 times the smallest variance.
Yes.
And that just seems weird. You think 4 times larger is pretty far from equal.
I know. Yeah, really. That's significantly larger.
Mm-hmm.
Okay, so an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? And I put 6, and I just plotted it out. Do you know of a better way or easier way to figure it out, Meredith?
No, I did the same thing. I just wrote them all out.
Yeah. Okay.
I'm sure there is some formula you can use, but I don't know it.
Yeah, I just was wondering if there's 100 samples that we're, comparing, which who knows if we'll ever get that far. But anyway,
right.
By then we'll have figured out or we'll have been taught some other method.
I hope so. Because you guys just wrote the 4 pairs and then you just try to make sure you had one
of each pair.
Yeah.
Yep.
Yeah. Okay. All right. My turn. Question number 8. In the soccer
7. Oh no, you're right.
Okay. I was like, oh, okay. So in the file, the soccer shoes, it's asking for the minimum variance for the 6 groups. It was 5.216.
I have 27.207.
Okay, so then let's go back.
Is 5 point whatever, is that the standard deviation?
Yes.
You have to square that to get the variance.
Ah, okay. I'm glad that
That's what we were unsure about.
Yeah,
I don't remember
so S is the standard deviation. The variance is S squared.
Okay. I do remember seeing that S squared, but I didn't do any problems like this unless I got them all wrong.
Okay, so
yeah, we haven't really talked about this since way back.
Right.
And there was a question about what does this number at the bottom of the box mean, and it wasn't any of those things. That was the variance, and that wasn't one of your options. So I remember that question from a long time ago.
Right.
But yeah, we haven't done anything with variance in a long time.
Yeah. So you got 27.207?
Mm-hmm.
Okay.
Yep. So
unless I'm doing it wrong, but I think that's the variance is S squared. So.
You're right. It is S squared. I remember that.
It never had us figure out
the
variance for any of the worked examples. So.
Okay, so then the next one is going to be, we got 7.291, and that would be squared. Which would be 53.159.
Yeah, that's what I got.
Thank you, Meredith.
And so I think it said somewhere in there that if you're looking just at the standard deviations, if one of them is twice as big as another, then the variances will be 4 times as big. You can kind of tell without having to figure it.
If it's twice as big, okay.
Yeah.
Once you compare it, that makes 4 times.
Okay, I do remember that. Okay, I don't know whose turn it is. But we got 53.159 for 9, right?
Yeah, that was mine. Do you want me to skip or just go to 10?
Oh, I'm sorry.
Go to 10.
Yeah.
Okay.
Unless you're...
Well, the test, that's fine. I don't care. Okay. The test for equal variance is satisfied for these data, and I put true.
Yes.
Jody's next.
Okay,
I'm out of which one? Okay, 11.
11.
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. I said true.
Me too.
Okay. Number 12, perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again, I think it is. What is the p-value when we remove the SOX data? No, so in order to do this, we just literally went in and deleted that data, and it seemed to
That's what
work.
I did too. I didn't know if
Okay.
there's some way to
We did
remove
not
it in the
not
formula.
Yeah.
I have no idea.
We just clicked on, just deleted it. Okay, and our answer was 0.309
Me too.
Oh, good.
for the p-value. Yes, okay.
Yeah.
But yeah, they didn't. That's what's frustrating is they don't give you any like, oh, if you need to do this, this is how you do it.
Yeah.
Yeah. Eliminate one of your factors, but yeah, I didn't. So there could be a way, but I don't know it.
Okay.
Uh-huh.
Okay. Number 13. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic? And I put right.
Yes.
And that right tail.
Mm-hmm. All right, question 14, moving on to the hot dog nutrition study. All right, so it says, let's examine the calories first. Construct the QQ plots for the calories and compare the variances. So this one, we thought it was either 1 or 2. I think it was 1, but we selected 1, the
I
top
put
one.
the first one too.
Yeah.
Okay. It made the most sense.
Mm-hmm.
I have a hard time analyzing the QQ plots because I don't know how far out it's far out.
We said the same thing. Because on the next one, or I think maybe it was in the homework, I'm not sure if it was this or the homework because I've done it all in the same hour. But there was one that, they looked similar.
Mm-hmm.
And yet it wasn't, it didn't qualify, so whatever.
Right.
Yeah, well, farther down in this quiz where it says you'll notice that the QQ,
Right.
here,
Don't
the
add up.
poultry has a possible problem. Like, well, I don't look the same as all the other ones.
You're right.
I don't know.
I don't
Right.
either. Hopefully we won't be tricked like that or, tested so obviously. Yeah. Okay. Is it my turn? I think it is.
Yes, number
know.
15.
Number 15, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F is 16.074, and that P is 0.000, with a level of significance equal to 0.05. What conclusion can you draw? We said we have sufficient evidence to claim that at least one, that's the fourth one, that at least one of the hot dogs has a different mean number of calories than another type.
And that's what I put too. Question though.
Okay.
Like, it keeps asking us what the degrees of freedom are, but we don't ever do anything with those, right?
That's and why do we have 2, and what do you do with the 2 different, they're very different, so it doesn't.
So there's nothing
knows?
we need to know about them, it's just know to where to find them.
Yes, and we don't use the total. We use both of them. Or
The top 2.
pick of us. Yeah.
Yeah, it doesn't make sense because we never plot or we never put anything into like an probability app,
Right.
Yeah, it just seems like useful information.
Well, and on the homework, we were supposed to sketch. We just sketched that, like made our own little right skewed plot graph. Is that correct? Is that what you guys did?
Yes.
When we were supposed to sketch it, I didn't know how I was supposed to do that on like SPSS.
Hard to know how to do that.
It is.
Yeah.
I just kind of made it up.
I couldn't try to miss anything about these degrees of freedom.
Yeah, not that I know of.
All right. Well,
Yep.
Okay.
Moving on.
All right.
16.
So am I next?
I think I don't know. I haven't gone in a while.
Take it, Meredith.
I think we're out of order, but it's fine. So this is the one. Now let's examine the sodium levels. Construct QQ plots for the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normal assumption. The smallest variance is Yeah.
Not at all.
No. I mean, they don't touch the line. Is that all you need to know? Is that the circles aren't touching the line?
Plenty of them didn't, though,
Yeah. So the smallest variance is 7180.75, and the largest is 10492.871. Have the assumptions been met to use ANOVA? I chose the third one since they did mention the poultry thing and said the assumptions have not been met. Sorry, my finger's making noise. My Little Pony game.
I know that tune. That's funny.
Oh, kids. So anyway, is the third one? The assumptions have not been met. It's not safe to assume each group comes from a normally distributed population. We can assume that the variances are equal.
Okay, we put number 2. Well, we put number 2, but I'm open to other options. Let me just see.
How can we assume that the variances are equal?
Because the smallest variance is not half the size of the largest, or
Okay.
4 times as small as the largest. So the variances
Okay.
are out within the bounds.
And we know that the assumptions have not been met because it already told us that one of the up above is not. Okay. All right.
Right.
That makes sense.
Yep.
So
But this is possible problem. I don't know.
I know. No, that does
This
make
makes
sense.
sense.
Because I didn't
We
pay
may have to redo
attention.
16.
All right, so 17. I'll go ahead.
Okay.
Despite the possible problem with the QQ plot for poultry, you decide to use an ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value? We got 0.179.
That's what I got.
Okay, good. What? Okay. What conclusion can you draw about this mean sodium levels of the 3 types of hot dogs? Use the level of significance of alpha equals 0.05. We said we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same medium sodium levels. That's B.
That's what I put too.
Okay. It's the only one that says essentially fail to reject, but I hate these double negative things. We do not. I mean, like, I don't know. It seems like it, at least in
We
this
do
one.
not have sufficient evidence to reject. Yeah. Because you can't ever say you have sufficient evidence. It's just always,
Right.
anyway, like, not in this case anyway.
And then it's funny because they're like, state in plain English. I'm like, it's not in plain English.
That's a very good point.
Well, I submitted and we got 100%, so good job.
Yay.
Awesome.
So we were right with 16.
Yes.
Yes.
We were. Well done. You were right. We didn't even look at the very. We should have been like, oh yeah, that's not 4 times. Like, we didn't look. So good job.
Yeah. So I did have one question on the homework. Hold on. I'm just going to go ahead and stop the recording.